So in this video we are going to see the effect of the presence of different types of inhibitor on the shape of a double reciprocal plot or Lineweaver Burk plot. And such plots are described by this double reciprocal equation that we have here. So in the absence of inhibitor, we would have something like that. No inhibitor. And the position, so the slope, of course, will be the ratio between Km and Vmax. But we usually analyze the plot by determining the plot's intercepts. So the y-intercept here will give us 1 over Vmax. And the x-intercept here will give us minus 1 over Km. So that's in the absence of inhibitor. What will happen in the presence of a competitive inhibitor? So competitive inhibitors will not change the maximum velocity of the enzymatic reaction, but they will increase the Michaelis-Menten constants. So it means that the y-intercept will not be changed, but since Km gets higher, because alpha and alpha prime both are higher, more than 1, the distance here that the line will kind of leave on x-axis will be smaller, right? So this will be my new x-intercept in the presence of a competitive inhibitor. So I expect my double reciprocal plot to look like that. So what happens if I have uncompetitive inhibition? In this case, both my maximum velocity and my Michaelis-Menten constant are decreased by the same factor. And as a result, my slope will not change. If my slope doesn't change, it means that my line describing the relationship between the initial velocity and total substrate concentration will be parallel to the line in the absence of inhibitor. Sorry, I cannot draw it nicely parallel, but it should be parallel. Parallel, kind of. It's a little bit tilting in one direction. It's difficult to draw this line just by hand, like that, parallel. So this will be those distances. I don't like when it's not parallel. It should be parallel, but it's not. So those distances should be the same, right? So that the ratios of apparent maximum velocity and maximum velocity in the absence of inhibitor, and the ratio of apparent Michaelis-Menten constant and the constant in the absence of inhibitor should be the same, right? So what happens if I have a case of mixed inhibition? In this case, definitely my maximum velocity decreases the same factor as it would decrease in the presence of uncompetitive inhibitor. But my Michaelis-Menten constant can be either increased or decreased or not changed, depending on the values for alpha and alpha prime. So if I have alpha equal alpha prime, then it means that my Km doesn't change, right? But my Vmax should be decreased. It means that the intercept is higher now. And this is a case of non-competitive. So alpha equals alpha prime. If I have alpha higher than alpha prime, so alpha is higher than alpha prime, then my Km will be increased. And so the x-intercept, its absolute value, will be decreased. So I'll have something like that. Right? That's alpha higher than alpha prime. So if I have alpha less than alpha prime, then my Km will be decreased, and of course my Vmax is decreased by default, and so I will have a curve that looks like that. So that's a case of mixed with alpha less than alpha prime.